Chau,
I'm Souhrada.
I'm Abhimanyu Varma.
and we're Team 1087 competing in SCUDEM 2024, solving for Problem B, Narrative Influences. Our coach is Major Ivan Bermudez, and we're representing the United States Military Academy.
Problem outline. Research indicates that a person's mood influences the effectiveness of messaging. We are asked to analyze two different movements. Persuade movement, attempting to get people to agree to a set of actions, and dissuade movement, attempting to get people to disagree to a set of actions. Our goal is through a mathematical model, analyze how mood influences the efficacy of each movement and determine which movement will be more successful. Research. A study published in the Health Marketing Quarterly investigated the effect of mood and messaging type on how an audience processes the information in an advertisement for a vaccine. More precisely, the study defined three dependent variables that measured the effectiveness of the advertisement. Recall is the capacity to remember specific information in the advertisement. Evaluation is how convinced the audience felt after watching the advertisement. And behavioral intent is how likely the audience would change actions because of the advertisement. Existing research indicated that mood and messaging type can trigger the same type of mental processing. Based on this, the study hypothesized and concluded that a mood congruence effect can increase an audience's recall, evaluation, and intent. A positive mood maximizes the effect of persuasive narrative messaging. A negative mood maximizes the effect of dissuasive ungrouped messaging. However, whether positive or negative mood congruency is more effective remains unanswered. Modeling scenario. Our scenario is, suppose that there are two competing movements, a persuade movement and a dissuade movement, in a town with a population of 100,000 people. Over the course of a month, which movement will be more successful? Efficacy is defined as the percent of people who comply with the movement's goal. Persuade efficacy is defined as the percent of people who carry out the advertised set of actions, whereas dissuade efficacy is defined as the percent of people who refuse the advertised set of actions. We use the base SIR model, typically applied to how an infectious disease spreads throughout a population. Cross-applied, it can be used to see how information and actions spread throughout a population. There are three stages: susceptible, which is not yet exposed to either movement and able to be influenced; infected, exposed to one of the movements; and recovered, carrying out the goal of one of the movements. Coefficient of spread is calculated by averaging the means of recall and evaluation found in the study. Coefficient of intent is based on the mean of behavioral intent found in the study.
So the base SIR model only includes the susceptible, infected, recovered. We modified it to assess the effects of two different movements, quote-unquote diseases, being applied to a population, and including how some of the movements will result in crossovers between the two intended actions. So the variables we had were T, which represents time, S for the susceptible population, P for the number of people exposed to the persuade movement, D for the number of people exposed to the dissuade movement. R sub P is the number of people who comply with the action after exposure, with the persuade action. R sub D is the number of people who reject the action, right? The parameters are alpha is the coefficient of persuasion spread, beta, which is the coefficient of dissuasion spread, gamma is the coefficient of dissuade intent, delta is the coefficient of persuade intent, epsilon is the coefficient of persuade from dissuade exposure, and lambda is the coefficient of dissuade from persuade exposure. These are the equations that come out of analyzing the model to the right. You see all the equations result from a basic rate in, rate out relationship between the two resulting actions.
Our assumptions are closed system. The total population does not change and only the two movements can influence the resulting efficacy. Neutral mood. All people start with a neutral mood and are equally susceptible to either movement. Complete exposure. All people will be exposed to a movement. And complete intent. All people will decide whether or not to comply with a movement's goal. Binary selection. If a person fails to be convinced by a movement, they automatically comply with the goal of the other movement. If an individual fails to be convinced by the persuade movement, they will not perform that set of actions. If an individual fails to be convinced by the dissuade movement, they will perform the set of actions.
So we look at our simulations from our differential equations, we see that we meet our assumptions, and we see that we meet the expected behavior. For S of t, which is a susceptible population, it starts off at 100,000, which is the starting population in the town, and crashes to 0 around halfway through the month, around 15 days. As S of t decreases, we see increases in P of t and D of t. That's the orange and green graph respectively, which indicate that the people who are originally susceptible are becoming exposed or infected by the different movements. We see that as S of t, which is 0, we see peaks in the P and D of t graphs, which makes sense because once there's nobody susceptible left, that means everybody has been exposed either to the P of t graph or the D of t graph. And as P of t and D of t decrease, we see increases in our P of t and our D of t, which are the red and purple graphs respectively. These indicate that as less people are exposed, they're sewing themselves into either performing the action of the movement or not performing the action of the movement. And that shouldn't make sense. And as we can see, everybody eventually chooses to comply with the action or not to comply with the action, which is why they level off in the RP and RDT of the RP and RD of T graphs. And one last assumption that we meet that was very important in creating this model is the fact that everything adds up. Everything adds up to 100,000. We can see that in the middle, everything adds up back to 100,000, and in the end state, when everything levels off, it adds back up to 100,000. So it meets our assumption that this is an isolated system and nobody entering or leaving the system.
Right, and as a result, by the end of the time frame, 72% of the people would be exposed to the persuade movement, 28% were exposed to the dissuade movement, 83% of the people will actually carry out the set of actions, and 17% will deny the set of actions. As a result, we can say that positive persuasive messaging is not only more conducive, but also not only more conducive to spread, but also to behavioral intention.
The implications. So we look at a model, we're equating information and the spread of disease, and this can be used by policymakers and public health experts to study how the messaging affects the general public health. For example, we look at what happened with COVID, the US spent over $377 million on campaigning for the vaccine, and that equated to 81% of the population receiving at least one dose. It begs the question of whether or not more people would have been vaccinated, or what if they could have spent less money if they had a more effective model, if they could predict whether positive or negative messaging would have been more effective. And while the model was based on data solely for vaccine advertisements, it also begs the question of whether or not we can cross-apply this to other industries. Imagine politicians or elected officials using this for elections and trying to sway voters' decisions of whether or not to vote for this or not to vote for this. And this model allows you to predict the outcomes of a positive or negative message in those contexts, essentially allowing you to maximize the rate of a desired outcome. When we talk about limitations and what we can improve in this model, the data, first off, was based off a sample taken from a Midwestern college population that was disproportionately female, which indicates that we may not be able to generalize this model to people outside of the college population age range or outside the college population demographic, or equally apply it to males and females. Also, the methodology in the study assumed that the mood was pre-induced. That is, they pre-induced the mood through music and through other factors. We assume the message itself can induce the mood, and to improve the model, we should research how effective messages are at inducing mood, the content of the message itself, not any outside factors. It's also an isolated system, which doesn't account for any potential influences from outside the sample population. We only assume there's two movements. The parameters itself don't have any inherent meaning because, one, there's no tangible data. They're calculated on maintaining the relevant relationships between the study statistics rather than an actual data set. And the main improvement in the data will be running an experiment with a model and seeing if it complies. Because, again, we didn't have any empirical data, so we had to make the parameters based on maintaining the relative assumptions and relative relationships between the statistics from the study. So the next improvement would be performing an empirical experiment and fitting that data to our parameters. These are our references. Thank you for listening, and thank you for your consideration.